Hello, in this problem, there are three cars driving along the road at various cases. We are asked to find their value of their deceleration at each point, while the ground is still flat if they all slam their brakes and begin skidding. In each case, we're given a velocity of 20 meters per second, a radius of 200 meters for parts B and C, and a coefficient of kinetic friction of 0.9. For part A, the car is traveling in a straight line, so the forces on the y are going to be 0. The forces on the x, however, are going to be ma sub x. The force on the x direction that we're interested in is the kinetic frictional force. This is going to be equal to mu sub k times the normal force. And since the normal force is equal to the weight force, we can just say that the frictional force is equal to the coefficient of kinetic friction times mg. Then we're going to plug that into the equation for the sum of all forces in the x, which is ultimately going to give us that deceleration value. So we get a total deceleration of minus 0.8 meters per second squared. For part B, it's going to be quite similar, but we're now dealing with a centripetal acceleration. We need to find the equation for the sum of all forces on the x direction, and we're going to use that to find the acceleration in the x, which is going to be our deceleration. First, we need to find the sum of all forces on the y. Since we're given a radius, we know that the centripetal force will balance the forces in the y. This gives us the equation F sub c is equal to mass times centripetal acceleration, which is also equal to mass times velocity squared over the radius. This equals the normal force on the car minus the force of gravity on the car. Similarly to part A, we're going to need to solve the normal force so that we can plug that into the kinetic friction force equation, which gives us this. We then need to plug in the equation a sub x is equal to minus force of friction over mass, and that'll give us a total acceleration of minus 10.6 meters per second squared. For part C, it's basically going to be the same thing, except since the car is on the top of the hill, we're now going to have the centripetal acceleration pointing downwards to the point of the circle. This is basically going to give us a negative ma, which is going to give the sum of all the forces in the y is equal to the negative normal force plus force of gravity on the car. We're going to have a negative ma, so this is where it can be confusing because it gives us negative mb squared over r plus mg as being the normal force. Whereas in part B, we had a positive mv squared over r plus fg. Like part B, we just plug in the normal force into the equation for kinetic frictional force, which we plug into the acceleration we plug into the forces, the horizontal force equation, which will ultimately give us the acceleration in the x for that instance, and we get an acceleration of minus 7.02 meters per second squared. Thank you.